Hi everyone, and welcome back to the channel. Today, we're diving into a topic that's everywhere right now: artificial intelligence. We hear about AI doing incredible things, from creating stunning art to driving cars, but have you ever wondered how it actually learns? It sounds like something out of a sci-fi movie, but the basic ideas are surprisingly easy to grasp. So, grab a coffee, get comfortable, and let's demystify how AI gets so smart. First, let's clear something up. When we talk about AI learning, we're not talking about it having a brain like ours. It's all about math and data. Lots and lots of data. Think of an AI as a baby, but instead of learning by touching and seeing the world, it learns by sifting through massive amounts of digital information. This process is called machine learning, and it's the engine that powers most of the AI we interact with daily. There are three main ways an AI learns. The first and most common method is called supervised learning. Imagine you want to teach an AI to recognize pictures of cats. You would feed it thousands, even millions, of images. For each image, you'd give it a label: cat or not a cat. The AI's job is to find patterns. It looks at all the cat pictures and starts to figure out what they have in common: pointy ears, whiskers, a certain eye shape, a furry texture. Initially, its guesses will be terrible. It might see a picture of a dog and say, "Hey, that's a cat." But because we've labeled the data, we can correct it. We tell it, "Nope, that's a dog." Each time it gets an answer wrong, it adjusts its internal logic. It's like a student doing a practice test, checking their answers, and learning from their mistakes. Over time, after seeing countless examples and getting corrected again and again, the AI becomes incredibly accurate at identifying cats. This is exactly how your email spam filter works. It has been trained on millions of emails labeled as spam or not spam to learn how to protect your inbox. Now, what if you don't have nicely labeled data? What if you just have a huge, messy pile of information? That's where the second method comes in, and supervised learning. With this approach, you give the AI a mountain of data without any labels or instructions. You just tell it, "Find some interesting patterns in here." It's like giving someone a huge box of mixed Lego bricks and asking them to sort them. They might start grouping them by color, then by size, or maybe by shape. They're creating their own categories based on the inherent properties of the bricks. An AI does the same thing with data. For example, a streaming service might use unsupervised learning to analyze the viewing habits of millions of users. The AI might discover a group of people who love sci-fi movies and also listen to classical music. It finds these clusters or groups all by itself. This is super useful for things like personalized recommendations. The system doesn't need to be told what types of users exist. It discovers them on its own, which is why your favorite app can suggest new songs or movies you might actually like. So we have learning with a teacher, which is supervised learning, and learning on your own, which is unsupervised learning. But there's a third, really cool method that's more like learning through trial and error. This is called reinforcement learning. Think about how you might train a dog to do a trick. When the dog sits, you give it a treat. The treat is a positive reward. If it does something you don't want, you don't give it a treat. The dog gradually learns that the action of sitting leads to a reward. Reinforcement learning works the same way for an AI. We place the AI in a virtual environment, give it a goal, and set up a system of rewards and penalties. For example, let's say we want to teach an AI to play a video game. The goal is to get the highest score. The AI starts by just pressing buttons randomly. If it does something that increases its score, like collecting a coin, we give it a virtual reward point. If it does something bad, like running into an enemy, it loses a point. That's the penalty. The AI has one mission: maximize its reward points. So, it will start to favor actions that lead to rewards and avoid actions that lead to penalties. It plays the game millions of times, constantly experimenting and refining its strategy. Over time, it can become better than any human player. This is the exact technique that was used to create AI systems that have mastered complex games like chess and Go. It's also crucial for robotics, where a robot can learn to walk or pick up objects by trying different movements and getting rewarded for successful ones. So, to recap, supervised learning is like studying with a textbook and an answer key. And supervised learning is like being a detective looking for clues in a giant pile of evidence. And reinforcement learning is like learning a new skill by getting rewarded for success and learning from your failures. These three methods are the foundation of how AI learns. But the secret ingredient, the thing that makes it all possible, is something called a neural network. This is a computer system inspired by the structure of the human brain. It's made of layers of interconnected nodes, or artificial neurons. When you feed data into the first layer, each node processes it and passes it onto the next layer. Each connection between nodes has a weight, which determines how much influence one node has on another. When an AI is learning, what it's really doing is adjusting these weights. Let's go back to our CAD example. When the AI first starts, all the weights are random. When it makes a mistake, an algorithm goes back through the network and slightly tweaks the weights of the connections that led to the wrong answer. After millions of adjustments, the network is perfectly tuned. The connections that are good at identifying CAD-like features become stronger, and the ones that aren't become weaker. This is why AI needs so much data and so much computing power. It's running through these cycles of guessing, checking, and adjusting millions or even billions of times. The more complex the task, the more layers and nodes the neural network needs, and the more data it requires to get properly trained. This is what we call deep learning, using these really deep, multi-layered neural networks. So, is AI really thinking? Not in the way we do. It doesn't have consciousness, feelings, or understanding. It's a highly sophisticated pattern-matching machine. It has learned to associate certain inputs with certain outputs through a mathematical process of optimization. It's a tool, a phenomenally powerful tool, but a tool nonetheless. It's a reflection of the data we feed it, which is why it's so important that the data is fair, unbiased, and representative of the world we want to build. And that's the basic gist of it. From being a student with a teacher in supervised learning, to being an explorer in unsupervised learning, to learning through trial and error with reinforcement learning. AI uses these powerful techniques to make sense of the world. It's not magic, it's just very clever math and a whole lot of data. I hope this helped you understand a little bit more about the fascinating world of artificial intelligence. It's a field that's moving at an incredible pace, and understanding the basics is the first step to appreciating just how much it is going to change our future. What part of AI do you find most interesting? Let me know down in the comments. I'd love to hear your thoughts. If you enjoyed this video and learned something new, don't forget to hit that like button and subscribe for more deep dives into science and technology. Thanks for watching. And I'll see you in the next one.